Okay, one more thing I forgot to add. So we're not quite done yet. Okay, so one thing I forgot to say, I misspoke. We can conclude that this sequence of partial sums is bounded. Okay, so since this partial sum is always less than 2 minus 1 over k, and so as k goes to infinity, well, we can say that the sequence of partial sums is less than 2, because the limit as k goes to infinity of this is equal to 2. So we know it's bounded above by 2, right? So we know that this is bounded above by 2. Okay, so now, the other thing too is we can show that this is an increasing increasing sequence, right? So this is increasing. Right? So how do we show that? Well, easy. And this will just take a second. So we've got S1 equals 1, right? And then S2 equals 1 half squared. And then S3 equals 1 third squared. Oh, hold on a second. Sorry. Keep dropping this. Okay, and then this is going to be 1 plus 1 over 2 squared plus 1 over 3 squared. Okay, but this can be written as what? S1 plus what? 1 over 2 squared. And S3 can be written as what? S sub 2 plus 1 over 3 squared. So if you keep going, well, we can write S sub k is equal to what? S sub k minus 1 plus 1 over k squared. Okay, so now you can see that since k is always positive, that we're always adding a positive value, and so we can see that S sub k that S sub k is always greater than S sub k minus 1 for all k greater than or equal to 2. Okay? And so now, what do we show? Okay, so this means that what do we have? We have an increasing and bounded sequence. So what theorem do we use? We use the what? The monotone convergence theorem. And so the monotone convergence, what is a monotonic or a monotone sequence? One that is bounded and what? Increasing or decreasing. Okay, so by the monotone convergence theorem, this sequence converges and therefore the series converges. That's the end of it. Okay, see you next time.